is a polynomial inequalities. And this is section 3.10. Okay. So if we have a polynomial f of x is equal to x plus 2 times x minus 3 squared times x plus 4. Okay. Go ahead and graph that. It's already factored for you. Just sketch a quick graph of that. It looks something like that. Where does it cross the y-axis? Well, we can find out though, right? Find the y-intercepts. Find the y-intercept. So to find our y-intercept, what do we need to do? Plug in 0 for x. See what you get for y. So you end up with 72. And so that's where it's crossing the y-axis, right? Okay. So if based on this, I'm going to ask you a few questions and give me an answer. So, so part A, solve this equation here. So x plus 2 times x minus 3 squared times x plus 4 equals 0. Quickly write down the solution to that problem. Use what we've already done. Use the graph to help you. All right, who's got an answer? All right, Diego, what's the answer? No. Nice try, but no. Michael, what's the answer? What is it? Yes. So the answer is going to be x equals -2, x equals 3, x equals -4. Because this is asking what values of x give you a y value of 0, right? This is our function here, and all the points on the x-axis, your x-intercepts, have a y value of 0, and you can solve for those x values, right? So this is saying what are those x-intercepts? And if they're imaginary, then they wouldn't be x-intercepts. But what are the zeros? What are the roots of that function? Okay. All right. What if we change it to this? To solve, I'm going to give you the same left side. So x plus 2 times x minus 3 squared times x plus 4. But this time I want your answer, all x values that would make this greater than 0. Instead of changing it to an equal 0, I'm giving an inequality. Use the graph to help you answer that. Anybody feel like they can answer that correctly? If not, I can go over it. Chase, what do you think? X what? It's not. You're not going to have an equal sign. This is going to give you intervals. It's going to say all x values from here to here or here to here. Yeah. X greater than -2. X greater than 3. And x greater than 4 is what you're thinking? -4? Okay. So if you say like x greater than -2, and I go to my graph, that's saying everything. Well, actually, let's go x greater than -4. If you say x greater than -4, that's going to take everything from -4 past it. So you wouldn't even need the above because that would include all this stuff too. Unless you want to say go above -4 but stop at a certain point. Which are you meaning everything above -4? Or okay. So you would just say, hey, just throw those out. You just take everything above -4. So everything from -infinity to -4. So you're going to give me interval notation. That's fine. -2 to infinity. Okay. Oh, but there's something going on at 3. Okay, so let's take a look. So we know it's equal to 0 where it's crossing the x-axis, and I'll put some boundary lines here. So there's something. These are your critical points on the x-axis. On the left side of this boundary line is the y value positive or negative? Positive. So this is what Mr. Dempsey likes to do. So he's going to say, okay, all that's positive there. And then what happens between these two? Okay, so everything's below, so that you got negatives here. And then between these two, everything is above the x-axis, so these are all positive. And then what happens over here? Still positive. But notice it's not positive at that boundary line because that's when it's at 0, right? So something happens there. And so what I was asking you in this problem is, where is it greater than 0? So where are those plus signs is what I'm asking, right? And it happens at three locations or 3 intervals. So one interval is right here, and I'm going to say from -infinity to -4. And should I use a bracket or parentheses on the -4? It's got to be a parentheses because I said it's got to be greater than. If I use the bracket, that means it could be equal to 0 as well. And we can't have it equal to 0. So you got to use parentheses there. The next part here would go from where to where? So this is your -2 to 3. And I have to use a parentheses on 3 because there's a break there. You can't equal 3. And then you pick back up at 3 and go to infinity. So these two together say everything from -2 to infinity except for 3. That's a fancy way of saying that. So you want all 3 intervals together as your answer. So negative. Right, and you're going to put a union sign between them. So that's the answer to that part B. Okay. So I'm going to adjust this just a little bit for part C. And by the way, giving those answers before I even tell you how to do it is, you guys would get close there. Okay, but now you see this, so try this on part C. Solve, same thing, x plus 2, x minus 3 squared, x plus 4, but this time I'm going to say greater than or equal to 0. It's going to be similar, but there's a couple adjustments that need to be made because of that equal sign. Anybody want to try this one? Thank you. So, is it going to start the same? We go from negative infinity to negative 4? Except what's going to be different here? Bracket, because we can include that negative 4. We're allowed to have that. And then start back up at negative 2. Can I do a bracket or a parenthesis at negative 2? Do I have to stop at 3 on this one? No, so this one you're allowed to keep going to infinity because we're allowed to have that 3. So we, instead of having two separate intervals broken at that 3, we just combine them one. Okay. I'm going to give you one more to try. The same thing, but make it less than 0. So write the solution to that. This one's maybe a little easier to do, right? Anybody have a, yeah? Okay. You guys good with that? Because it's got to be less than 0. If you put a bracket, that means we can plug a negative 2 in. And if you plug negative 2 into this function, you're going to get exactly 0, not less than 0. Less than or equal. Actually, this is interesting. If we had the less than or equal to 0, if I had put that, just what would the answer be? You'd have the brackets, negative 4, negative 2. What would that be it? But then you'd also have to say and x equals, or x equals 3, not and. Okay. So you wouldn't have an interval for the second part, but there's that one point that would work for you that you'd have to include on that. Okay. Well, x can't be something over here and that at the same time, so we say the word or. So now with that in mind, let's take a look at the homework. And I'll do a little bit with you. But that's what we just did right there is the new part. Okay, there's not a lot to it. So we're gonna incorporate what we know about graphing. You definitely want a graph to help you with these things. But once you have a graph, you just got to read the graph. Okay. So let's do number 10 together. So we have b to the 4th minus 16 is less than 0. And first thing you want to do is get a graph for this. And we have different techniques to get a graph now. We have factoring. Factoring is something that you want to rely on first. But if factoring doesn't work, then you can guess and check using the synthetic division table. That will work as well. Any ideas? You guys are the growing experts here. Soap? Oh, that's the cubes, not the 4th power. If you had a difference of two cubes or a sum of two cubes, that's when we use the SOAP idea to help us with the factoring. You can see it as a difference of 2 squared. So you can go b squared minus 4 times b squared plus 4. So yes, you can factor it as a difference of 2 squared. Still less than 0. You could do it again. So with both of them or one of them, just the one with the minus sign. Okay, so this is b plus 4, b minus 4, plus 2 minus 2. And b squared plus 4. Okay. And we're after a graph now. We're using variables like b or a or those kinds of things, but you can still think of it as an x variable, okay? So what are our roots? We have, how many roots are we going to have? 4. We have 4 roots, but 2 x-intercepts is what you're meaning, right? So we have 4 roots, so this one's going to give us -2. This one's going to give us +2. And then what will our others be? Okay. If you solve this, you get b squared is -4. And then take the square root, and you get b is plus or minus the square root of -4, which is plus or minus 2i. So those are imaginary. Those will not show up on the graph. But do notice that they come in conjugate pairs, positive 2i, negative 2i. So if we sketch a graph to help us with this problem, the only things that matter are at 2 and at -2. Those would be our critical values here. And we have to know which way this graph goes. Like on the right end, is it pointed up or pointed down? Pointed up. Passes through. So it's not a parabola, but it kind of looks like one, right? And so then after you graph it, I do want you to practice putting, okay, this is positive here because it's above the x-axis. It's going to be negative between, and then positive over here. I want to see that on your graph. After you have that, go back to the original problem and look at the sign. What does that mean? Does that mean above or below? So it's less than 0. And so then we're wanting this interval between -2 and 2. And because we don't have the equal, we don't want equal to 0. We just want less than 0. So our answer will be -2 to 2. And then you're done. Okay. All right. I'll do one more if you want, or you feel, unless you feel comfortable. Which one? Doesn't matter to me. What's that? Number 9? Okay. So a cubed plus 2a squared minus 4a minus 8 greater than 0. So first try is see if it factors. If it does, go ahead with that process. If it doesn't factor, then you got to use a synthetic table and guess. If you have 4 parts, what kind of factoring would you want to try? Factoring by grouping. So if we factor out an a squared, we're left with a plus 2. Factor out a -4, we get another a plus 2. So we know it's going to work out in terms of factoring. Factor out the a plus 2 from both of these terms. And we're left with a squared minus 4. I'm going to pause there, see if you could finish the problem.